Okay, I'm looking at our 7-4 homework, doing a little practice with some of the problems we have here, and I'm looking at the third one in particular. This is where we're just checking the sampling distribution for the p-hat. So we have a claim about a proportion being greater than or equal to 0.65. So that's what we'll use as our p for our n times p. So remember, we need n, which is 180, times 0.65 to be greater than a 5. And we need 180 times 0.35. Where do I get the 0.35? 1 minus 0.65. Both of those safely are going to be greater than 5. So a normal sampling distribution can be used here, since n times p hat. Actually, we would use n times p here, right? Greater than 5. And n times q greater than 5. So the subtle difference here, like when we're doing confidence intervals, we use p hat. When we have a claim, we can use the claimed value for p. Okay, so in a normal sampling distribution can be used. Select the correct choice below for our the null and alternate hypotheses. So the null claim, this is what they believe, is that p is greater than 0.65, right? So the alternate to that would be that we're looking for evidence that p is actually less than 0.65. That would contradict their claim. Remember, the idea with the null hypothesis, always make sure you have some semblance of an equal sign here, right? Notice I have greater than or equal to. Here I only have less than, or if I only have greater than, that would have to be in an alternate hypothesis. Okay. So critical value for the z-test statistic. We want to see, what value of z would be necessary for us to believe that p is actually less than 0.65. So if we can try to picture this in our sampling distribution. Our null hypothesis is going to be to go ahead and believe that p is actually equal to 0.65. We need to figure out what's this going to be so that we wouldn't believe in that anymore, right? So we need to think about our significance level here. And they give us an alpha, kind of a strange alpha. Usually alpha is like 0.05 or 0.01, but they give us 0.06, and that's fine. So what that means is any z-test statistics that we get that would only occur 6% of the time when this is true would lead us to reject the null hypothesis. So the easy way to get this would be inverse norm. And we can just inverse norm that 0.06 with a mean of 0 and a standard deviation of 1. And we have that on our calculator. And go to second vars. And inverse norm is number 3. I think this is easier than trying to look this up on a table, especially if you have the calculator right at your fingertips. So if we got a z-test statistic of negative 1.55, that would lead us to reject that null hypothesis. And it looks like we still have more pieces to this question here. If a normal sampling distribution can be used, identify the rejection region. So the rejection region is what I just graphed on there, right? We're going to reject it if z is less than what I just drew up here, right? Negative 1.55. That's our rejection region, just like I drew it here. We just found that this would be negative 1.55, right? Now, on the z scale, this would be 0, not 0.65, if that's confusing anyone. But a p-hat of 0.65 would be a z-score of 0. So negative 1.55 is a z-score that would be, and if we fall below that, we're going to reject the null hypothesis. It's significant enough evidence. Okay. All right, so now we want to find the test statistic. Again, I'll let the calculator do the work here. We got a p-hat of 0.6. So let's see what that looks like. So we go to stat, test, and this is a 1 proportion z-test. Okay, so in the 1 proportion z-test here, our null hypothesis was that p was equal to 0.65. Now, they don't actually give us x here, right? They just say p hat was 0.6. So what does that mean x was? Well, if the sample size was 180, x must have been 180 times 0.6. Okay, so I get 108. So 108 out of 180 is where I would come up with that p hat of 0.6. And of course, we want the alternate hypothesis there to go in the same direction that we already wrote on paper, less than. And I get my test statistic of negative 1.41, roughly. Two decimal places. Whoops. Okay. Check our answer. And then what would happen in that case? Well, we already said we'd need negative 1.55 or lower. Well, negative 1.41 is going to fall somewhere around here, right? It doesn't fall far enough out. So in this case, we would not reject the null hypothesis. We don't have enough significant evidence, right? So we fail to reject the null hypothesis. There's not enough evidence to reject the claim, okay? And then we can move on. So we jumped ahead to number 6 here. A medical researcher says that less than 79% of adults in a certain country think that healthy children should be required to be vaccinated. So think about that claim. That's a less than. That sounds like an alternate hypothesis. In a random sample of 600 adults in that country, 77% think that healthy children should be required to be vaccinated. Is there enough evidence to support the researcher's claim? Okay, so we first have to think about what would be the null and the alternate hypothesis here, right? His claim is that less than 79% of adults in a certain country think that healthy children. So there's no equal to in that statement. So that's going to be our alternate hypothesis, right? But let's go ahead and look at where we can spot his claim, right? What's his claim? His claim is not more than, for sure, right? It's not B, right? That's a two-tailed test. It's not equal to something. C says blank percent of adults in the country think that. Now, what he's claiming is that it's less than, specifically less than 79%. Okay? So now we want to frame that as a null and an alternate hypothesis. So remember, our null hypothesis always has to have an equal sign in it. So we would never do anything with letter choice A here. Okay? Remember what his claim was. He was claiming that this is less than 0.79, less than 79%, right? That's his claim. So that's the one I want. I want that less than. He wasn't claiming that it's less than or equal to. He straight away said it's less than. So our null, we're going to have to start off and say, well, our null hypothesis is going to be that it's, I usually would just say it's equal to 0.79, but we'll just go with greater than or equal to 0.79. He believes it's less than 0.79, and then we're going to look to see if there's significant evidence to reject the greater than or equal to claim and support his claim. So critical value. This depends on his alpha of 1%. So we can do that the same way we just did previously. I would just do, since it's a less than, it's left-tailed. So try to, again, remind yourself what this is going to look like. He's going to be impressed if he gets a statistic that happens less than 1% of the time. Remember, this is 0.79 lives here, so we need something that falls really far below 0.79 to confirm that it would be less than that, and we would reject it. So this is just an inverse norm on 0.01. Mean of 0, standard deviation 1. And we can run that on our calculator again. See if I still have it up here somewhere. Oh, there it is. Oops, I lost it. I'll just go back and run it down. Inverse norm. This time it's 1% in that little tail, and it's a one-tailed test. It's not two-tailed. Okay, so I get negative 2.33. That's going to be a z-score that's going to impress me. We get something at or below that. Identify the rejection region. So again, this is very similar to what we did in number 3. It's going to be a less than situation. And then the z test statistics. So we let the calculator do the job for us. Again, I'm glad we got a couple examples of this. So this is a stat test, and we were dealing with this week the 1 proportion z test. We had 1 proportion z intervals last week. So the sample statistic was 77% of 600. Okay, so we're testing against 79. He believes it's less than that. He gets 77% of 600. So we have to multiply that by 600. The calculator is going to need counts from us. It's going to need actual numbers. We can't say that we got 77%. Okay, and luckily we get a whole number. If you don't get a whole number here, just like we do with confidence intervals, make sure you round that to a whole number. And this was out of 600. And again, we're still going left-tailed. We're trying to find evidence that it's less than a particular claimed value. So I get a test statistic of negative 1.20. So we can see that that's not going to be impressive to us. We needed it to be negative 2.33. So we would not reject the null hypothesis here. There is not enough evidence to support the researcher's claim. Remember, his claim was that it's less than 79%, and we did not get 77. Even though 77 is less than 79, it's not significantly less than 79 with a 1% significance level and a sample size of 600. Okay, so I'm going to jump fast forward again here to number 9. Give that one a look. So here you have a researcher that claims 57% of college students work year-round. Right? He's just saying it's that number. In a random sample of 600 students, 342 say that they work year-round. At a 5% significance level, is there enough evidence to reject the researcher's claim? So in order to reject his claim, we need a two-tailed test here. And if it's a 5% significance level, I want you to keep in mind what we're dealing with now. He is just making a claim of equality. He's saying this is what it's equal to. So we're not investigating whether it's less than that claimed number, nor are we investigating whether it's greater than. We just want to simply say it's different from. So what happens is if alpha is 0.05 and your significant result can live in either tail, then what's really happening here is this is 0.025. You need to keep that in mind if we're going to look for a critical value or reconcile a p-value to these in some cases. So try to keep that in mind, that with a two-tailed test, alpha gets split up into two pieces. So here we go. Identify the claim in this scenario, right? Well, he claims that it equals 50%. 57%. Right here. I can't get my finger on it. 57% of college students work year-round. That's the claim. Real simple, equal sign. So we definitely want a two-tailed test. We want an equal to or a not equal to. Either it does indeed equal 57%. Remember, I'm going to shift to a decimal here, so it's a proportion. Okay, so we have equals 0.57, not equals 0.57, two-tailed test. Right. Find the critical value. So this is where what I meant by it can be a little bit tricky. And it says use a comma to separate answers as needed. So I'm glad I stumbled upon this one because we're going to have two critical values. We've got one down here and one up here. So it's going to be the same number. So if I inverse norm 0.025, so let me just back up. Let's change this to 0.025. And I get negative 1.96, right? So my critical values, it's the same thing on both ends of this. It's symmetric. So my one critical value is negative 1.96. The other critical value is positive 1.96. So if I get a test statistic that falls below negative 1.96 or above positive 1.96, that's where we're going to go ahead and reject the null hypothesis. So I need to write both of those in here. I think you can write them in any order, but you have to separate them with a comma. If you only write one of them, oh, you know what? It gives me the plus or minus. Let's see if we can get away with that. Let's see if we can just say plus or minus 1.96. That's how I would write it. So you have your plus or minus key here, and you Yep, let's just do that. It might be okay with the 1.96, negative 1.96. So the rejection region, what's happening here? The rejection region is these two tails here. It's everything outside of that. So this first answer choice is the non-rejection region, basically. So I need something like an OR statement. Here's what I want, right? I want when z is less than negative 1.96, I'll reject the null hypothesis. And I'll also reject it in that right tail when z is greater than 1.96. Okay, so oopsie, I didn't put my decimal in here. I wrote 196. That's not going to fly. So negative 1.96, sorry about that. Okay, so what do we get for our test statistic? This is where we're going to have to go to the calculator. What happened in here? 342 out of 600 said they work all year round. So we go to the calculator. We have our test. This week it is a 1 proportion z-test. We are testing it against that claim of 57% still. So that's going to be 0.57. And then we have to examine carefully the statistic they gave us. What happened here in this sample? 342 out of 600. So we're going to find that that is different from, the 600 is already there. 342, yep, out of 600, so we're good on the 600. 342 out of 600 is certainly different from 57%. The question is it significantly different, so much so that we would reject the claim of the 57%? So we go ahead and calculate, and I get a, so we get a p-hat of exactly 57%, right? Let me just double check that. 342 divided by 600. So we have no chance, if this really equals 0.57, we have no chance of rejecting the claim. We got a value that's exactly equal to that claim. So our z-score, our test statistic, was 0. It was no different from the... Okay. So would we reject the null? Certainly not. We would fail to reject the null. There is not enough evidence to reject his claim, right? His claim was that it was equal to 57%, and that's actually the statistic we got. So we don't have any evidence to the contrary of it. Okay.